Here is the solution to the web homework 2. So let's first draw a picture. So here is an x-axis, and we're going to assume that we're driving along the x-axis. And at some time, we notice that Bambi is on the road, and that will be our time equals 0, t naught equals 0. So this is our x-axis, and then we have to apply the brake. It takes us just a half a second to apply the brake. So the moment we start pressing on the brake, that's going to be our t1, and we know that that's equal to half a second. That's given in the problem. So this is when we apply brake. Okay, so then we slow down, and at time equals 2, sorry, not time equals 2, but at t2, we come to a stop. So let's label a few things. So this distance here, so we'll start at x naught equals 0, and we get to x1. That's the distance we travel before we hit the brake. Alright, now that is motion with constant velocity. And given that velocity, it's 20 meters per second. Okay, let's look at this other interval. This interval here, we'll label this endpoint x2. That's the distance we travel while braking. Right, distance traveled while braking, and we're told, not braking, and we're told that we accelerate with an acceleration of negative 10.0 meters per second squared. Okay, so let's write down a list of everything we know. So what we're given is, we're given acceleration when we're hitting the brake, so that's our negative 10.0 meters per second squared. We also know t1. T1, the moment we hit the brake, is 0.500 seconds. We could assume when we first notice Bambi that we're at the origin, so that's at 0 meters, and we know that our initial speed is 20 meters per second, and that is our speed at t equals 1 as well. Just the moment before we hit the brake, we're still traveling at 20 meters per second. And finally, we know our speed at t equals 2. Our speed at t equals 2 is 0. We come to a stop. Okay, so do we hit Bambi or not in this problem? Well, let's do some calculations. So the first time interval from t equals 0 to 0.5 seconds, that's motion with constant velocity. We have a nice formula for that. We know that x1 is equal to our initial position plus our velocity during that time, so v naught, times t1, our time interval. So x naught is 0, v naught is 20 meters per second, and t1 is half a second. So all of this gives us t1 equaling 10 meters. Okay. Now, that's the distance we traveled before we hit the brake. Once we've traveled that distance, we hit the brake. Then how far do we go? Well, it's motion with constant acceleration. What we know, we want to find the distance. What we know are our initial and final velocities. So I can use the following equation. I know that v2 squared is equal to v1 squared plus 2 times the acceleration times the displacement. So I want to find our displacement. The delta x is equal to v2 squared minus v1 squared divided by 2 times the acceleration. Okay, our v2 squared is 0, v1 is 20 meters per second, and we square that, and we divide by 2 times our acceleration, which is negative 10 meters per second squared. Okay. Plugging all that in your calculator, you can verify this, but you should get 20 meters. So that is our displacement on the time interval t1 to t2. So that distance is 20. So our total distance is the sum of t1 and our displacement in the other time interval. So total distance is just x1 plus our delta x, which is equal to 10 meters plus 20 meters, which is 30 meters. Good. So, do we hit Bambi? No. Bambi, we know, is, we're given in the problem, Bambi is 35 meters away. And so we have 5 meters to spare. So the question is, what's the fastest we can go initially so that we don't hit Bambi? Alright, so that's part B. The way to approach this is to know that we want our final position to be 35. Okay? And we can go back to the equations we have previously. We know the first bit of distance is given by this equation here. And I don't know what v is, but I do know what t1 is. So what I'm going to do, and I also know what x naught is. So we know x naught is 0, and we're just going to substitute in a speed for the speed that we're initially going, and that's what we want to solve for. So we have v times t1. So this first term here is the distance we travel at speed v before we hit the brake. Now, what about once we're decelerating? Well, let's go back to what we did up here. The displacement is given by this formula. We know what a is, and we know what our final velocity is. This v1 is the same v we had over here. So that's just v. So I can write out the displacement once we start braking as negative v squared over 2a. So this is the distance we travel. That second term is the distance we travel while braking. Now we know a few of the numbers. We have v. T1 is half a second. And we don't know what v squared is, but we do know a. A is negative 10 meters per second squared, so we multiply that by 2 and we get minus, you know what, I'll include the negative sign here to make it positive, 20 meters per second squared. Okay. This, if you notice, is actually a quadratic. I'm going to rearrange this equation here, and we can write it as v squared plus 10v minus 700 is equal to 0. So you can verify that, rearrange the equation, and you should be able to put it in that form. And you can use the quadratic equation to find what v is. V is one of two options. It's either 21.9 meters per second, or I believe the other option is negative 1.9 meters per second. Obviously, we don't want this value, so the maximum speed we can go without hitting Bambi is 21.9 meters per second.